Let's take some time to talk about section 10.3, which is about simplifying radicals. To simplify a radical is to factor out all perfect square factors and actually take the square root of those. So we've done some of this already. If I ask you to simplify the square root of 25, then you would write it as 5. If I ask you to take the square root of x to the 6th, telling you that x represents a non-negative number, you would take half of that exponent for x to the 3rd. Today we're going to talk about how you're going to simplify a radical that perhaps is not a perfect square. Let's say the square root of 50. 50 is not a perfect square. To do this, we're going to separate it into two radicals. And I start thinking about the factors of 50. Blank times blank gives me 50. The only rule is one of those two has to be a perfect square. So I choose 25 times 2. I can simplify the square root of 25 as 5, rational 5. I don't know what the square root of 2 is, so I leave it. This is considered the simplified form of the square root of 50. When it comes to radicals with variables, let's suppose I had x to the, let's say 11th. That is not a perfect square since that's not even, so I would have to factor it as well. When I factor it, it's actually easier to do the ones that have variables with exponents. If this is odd, then this term is not a perfect square. But if you simply take one away from any odd number, you get an even number. So if I take one away, I'll have x to the 10th. The one that I took away goes into the back radical. X to the 10th times x to the implied first is x to the 11th. The square root of x to the 10th is x to the 5th times the square root of x. And that is the simplified form of that. So if it's a perfect square, we take the square root. If it's not, we try to find the largest perfect square that factors into it. All right, let's look at our exercises in 10.3. Number 1, it says to factor the square root of 24, simplify by factoring. Okay, I have to think about 24. The largest perfect square that goes into it is 4. 4 times 6 gives me 24. The square root of 4 is rational 2. That's times the square root, of 6. That's what you would type into MyMathLab as your answer. All right, the next one. We have 4 times the square root of 80. This 4 is going to just tag along. The square root of 80. Now, I'm going to ask you to think of what's the largest perfect square. Some people come up with 4. That is a perfect square factor, but it's not the largest. Look at your list of perfect squares. 16 is the largest, and it goes in there 5 times. That gives me 4, that's that tag along, times the square root of 16 just happens to be 4, times the square root of 5. Your final answer for number 2 is 16 times the square root of 5. Let's look at number 3. The square root of 175. Well, what's a perfect square that goes into 175? You start thinking, and the answer turns out to be 25, and it goes in there 7 times. The square root of 25 is 5, rational 5, times the square root of 7. And that is the simplified form of 175. Number 4, simplify the square root of 25x to the 9th. Now, when I start to do this, it is not entirely a perfect square. The 25 is, so it goes in the front radical. X to the 9th, even though the number 9 is a perfect square, as an exponent, x to the 9th is not perfect because it's not even. So I will keep the even x to the 8th there and send one x to the back. That gives me 5 x to the 4th times the square root of x, and that is my simplified form. Variables are actually easier than the numbers. Number 5 is very much like that. You're asked to simplify the square root of y to the 9th. Well, that's going to be, take 1 away from any odd number and you'll have an even number, and there's a y. So it's going to be y to the 4th times the square root of y. And number 6, I have the square root. Let me scoot this over. I have this, got to find a good spot. The square root of 4x to the 8th, y to the 9th. Well, if I factor that, let's see, 4 is a perfect square, it goes up front. X to the 8th is a perfect square, it goes up front. Y to the 9th is not. Y to the 8th is, and I send a single y back here. So many times that 9 keeps showing up, and I'm sorry about the redundancy. That gives us 2, x to the 4th, y to the 4th, times the square root of y. That's my simplified form. Number 7, I have negative square root 320 x to the 8th, y to the 19th. As you perhaps almost play with this a little bit to try to find the largest perfect square that goes into this, well, it turns out that 64 goes in there, and it goes in there 5 times. Remember, you're trying to find a perfect square. X to the 8th is a perfect square. Y to the 19th is not, but y to the 18th is, sending a single y to the back. Keep the negative sign. The square root of 64 is 8. X to the 4th, y to the 9th, times the square root of 5y. Number 8, what's the square root of 9x to the 6th, y to the 10th? Well, I need to factor. No, I don't. It is a perfect square. 9's a perfect square, and both exponents are even. That's going to give me 3x to the 3rd, y to the 5th. So you have to watch out. You get so used to simplifying by putting 2 radicals, and then you realize that you have been given, I'm sorry, really making a mess of that, a perfect square. All right, number 9, use the quotient rule to divide and then simplify. Okay, the square root of 12 divided by the square root of 2, I can divide. That gives me the square root of 6. Can I simplify that? No, I'm done. Number 10, I have the square root of x to the 9th, y to the 7th, over the square root of x to the 7th, y to the 6th. Okay, the quotient rule says that I can subtract my exponents for like bases. It gives me x to the 2nd and a single y. Well, that can be simplified. Perfect square up front, x squared. Non-perfect square, plain old y. The square root of x squared is x times the square root of y. Done. All right, the next couple of problems involve something called the distance formula. So I'm going to get a little space right here and write down the distance formula for you. I'm not going to derive it, but I am going to write it down. Now, this is a formula that finds the distance between 2 points, x1, y1, and x2, y2. Point number 1 and point number 2. If I wanted to find the distance between those on a coordinate plane, let's suppose that I have a picture and I have a point 1 and point 2, and I could draw a segment, and I want to know how long that segment is. Here's the formula. Distance is equal to the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. You're going to want to write that formula down, and I don't think it's on your blue sheet, so you may add it to your blue sheet. All right, I'm going to use that formula to find the distance between these 2 points. These 2 points, I'm going to let the first point be x1, y1, And the second point, x2, y2. First point, second point. Distance is equal to the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. That will be big long radical. 2 minus a negative 3 quantity squared plus 4 minus 16 quantity squared. Minus minus, that turns into plus, so I end up with 5 squared plus 4 minus 16 gives me negative 12 squared. That is 25 plus 144, or finally 169. I need to simplify that answer. That is 13. The distance between these 2 points is 13 units. So this formula, I will just tell you, it comes from the Pythagorean theorem, but like I said, I'm not going to derive it for you right now. I'm just going to ask you to be able to use it. Problem number 12. All right, I'm going to go to the bottom because I am not going to have room to do this. So I will do number 12 down here. Sorry, I'm turning pages and that's probably rattling. All right, find the distance between 4, negative 8, and negative 3, 6. All right, the distance between those. Distance formula. X sub 1 minus x sub 2 quantity squared plus y sub 1 minus y sub 2 quantity squared. Filling in the numbers. That's going to be 4 minus a negative 3 quantity squared plus negative 8 minus 6 quantity squared. The distance is, and I'm going to get rid of these lines since I'm not following them anyway. Minus minus means plus. That's going to be 7 squared plus negative 14 squared. That is 49 plus negative 14 squared is 196. So the distance is the square root of 245. Now, when you get to problems 12 and 13, it asks you to give the answer 2 ways. First of all, simplify it and leave it as a radical. So, let's see. If I divide, well, what will go into 245? Well, I can't think of a perfect square, so I'm just going to see some of the factors. I'm going to divide it by 5 because I know 5 will go in there. Well, sure enough, it's 5 times 49, and 49 is a perfect square. So this is 7 times the square root of 5, and this is an exact simplified answer. Then my math lab says give a decimal approximation. So this time I know that the distance is the square root of 245, and that is approximately, using my calculator, it is 15.652478, and I don't think it wants all of that, and I look at the instructions again and it says round to 3 decimal places. The 4 says leave that as it is, so the second answer is 15.653. So this one is approximately. So on problems 12 and 13, you're going to simplify and leave as a radical for the first answer. You're going to get the decimal approximation round to 3 decimal places for your second answer. In the interest of time, I'm going to skip number 13 and go straight to number 14, which uses another formula. It's called the midpoint formula. The midpoint formula, finds the coordinates of a point halfway between two given points. If you have a point x1, y1, and a point x2, y2, then the point halfway between them on the coordinate plane, if I had a point here and a point here, then the point that's halfway between them would be, well, I didn't draw it very well, but it would be about there, and I'm going to call it XM, YM, M for midpoint. I need to pause this for just one moment. All right, let's look at problem number 14. You are given the point 4, -2, and the point 6, -1. I'm going to call this x1, y1. I'm going to call this x2, y2. I'm supposed to find the midpoint. All right, the x-coordinate of the midpoint is x1 plus x2 divided by 2. It's like the average of the x's. So it is 4 plus sign this time, 6 over 2, which gives me 10 over 2, or 5. The x-coordinate of the midpoint is 5. Y sub m is y1 plus y2 over 2. It's the average. That's going to be -2 plus -1 all over 2. That's -3 over 2. Because it does not divide evenly, I'm going to leave it. I have an x-coordinate. I have a y-coordinate. I am to enter these as an ordered pair. The midpoint is 5, -3 over 2. And number 15 is done just like this. Just watch out for your negative signs.